talk. I'm Lucas, one of the co-founders of Knowunity. And today I would like to tell you the Knowunity story, how we scaled from 0 to 9 million users in around 3 years, what mistakes we made along the way, how we grew the team, and how we overcame the challenges also in terms of scaling. One little disclaimer before we get started. Unfortunately, I woke up with a bit of a headache and a fever today in the morning, so it might be that I will need to take a few breaks in between and drink something. So please excuse me for that. But first of all, to give you a bit of context of what Knowunity even is, we basically had the idea for Knowunity around 3.5 years ago, when we were still sitting in school ourselves, and we were currently doing our A-levels in 2020, and noticed that there was actually quite a big problem in education. Many students are spending hours every single day on their phone. They have a platform for every single area of their interest, just not for the most important one, which is actually education. So therefore, we came up with this idea of building a peer-to-peer learning platform where students can exchange study material, where students can learn together with their peers, where they can build communities. Since we in the end believe that the whole social aspect of education is super important. And therefore, we built Knowunity with a strong social DNA. And yeah, that's the story that I would like to tell you today. So how did it all get started? As mentioned, we were still sitting in school, had the idea of building this learning app for students. We were talking with a lot of our peers, with friends, what would help them the best. And therefore then came up with the first idea of this edtech platform that we would build. And after a bit of brainstorming and speccing, we then also had to get to the implementation in the beginning of summer 2020. So the first thing that we had to actually do was to decide on the tech stack. We basically chose the tech stack based on three different criteria. On the one hand, we wanted to get to the market as soon as possible. And therefore, we had to choose a tech stack that we were already a bit familiar with. And since it was not really feasible for us to learn a completely new set of technologies. In addition to that, we always also had the ambition to build something bigger. So there was always the idea that potentially at some point we could be joined by additional engineers. And therefore, we also had to choose a tech stack which is a bit popular, for which you can find engineers. And the third criteria for us was that we wanted to not only build a platform for a few hundred users, but rather for a few thousand or millions of students. And therefore, we also had to choose a tech stack with which we wouldn't only succeed on the short term, but could also scale on the long term. So therefore, basically, in terms of the tech stack, on the mobile side, since we are a mobile-first application, we chose to go with Flutter, which is a cross-platform framework developed by Google. And the big advantage of that one is that we can develop the app only once. We only need to write one code base, and then can distribute it both to Android and iOS. And compared to more traditional approaches to building mobile applications, this saves us a lot of time, since we don't need to maintain two code bases and build every single feature twice, but can rather have one team and then in the end distribute the app both to Android and iOS. Apart from that, on the front-end side, on the website, we chose to go with React.js, but since we are mobile first and front-end on the web, it's not that important for us, or was not that important for us at that point of time. It didn't have as much as important. When it comes to the backend, we decided to go with rather something simple, a monolith written in Golang. And the main reason for us choosing Golang was on the one hand that it's super simple to learn to read and write, and especially nowadays, as we have more members on the team, we saw that backend engineers that have already had some experience with other languages were able to pick up Go within a few hours, and therefore were able to write their first commit on the first day. And apart from that, Go is also quite good when it comes to memory utilization. It has a very low memory footprint, and therefore it also allows us to scale cost efficiently to more users in the future. When it comes to the database, we chose to go with Postgres as our main database, relational database, rather a traditional choice. And then on the other hand, when it comes to the place where we store our content, we chose to go with S3, basically since we were running on AWS, and therefore it was also the most natural choice for us. Apart Apart from that, we decided to provision our infrastructure using infrastructure as code from day one, and therefore chose Terraform for provisioning the infrastructure, which on the one hand allows us to have a reproducible set of environments. On the other hand, use normal software development workflows like code review, and on the other hand also allows us to have a history of how the infrastructure and the architecture evolved over the course of time. We basically therefore went with quite a simple tech stack, but we still always had the ambition to build something bigger, and therefore wanted to be well prepared for the first few users. So therefore also from day one, we heavily invested into monitoring. On that side, chose to go with Prometheus as our monitoring metrics scraper, visualizing the metrics on Grafana as a dashboarding solution, and still get woken up during the night with PagerDuty in case anything goes wrong with the platform. Apart from that, also since we wanted to, or we already knew that there are different traffic patterns across the day. For example, in the afternoons when a lot of students come back from school, they are heavily using the application. Also in the evening, when they're still preparing for their exam on the next day, there are a lot of users on the platform. But then during the night, there are only very few users on the platform. Therefore, we also chose directly to set up auto-scaling, like then only based on CPU utilization, to ensure that we can handle the traffic during peak hours, and on the other hand, are cost efficient and resource efficient during the night when fewer students are on the platform. And basically, the two big learnings from this first period of time was that we wanted to get to the market as soon as possible. Our friends were all telling us, yeah, the application is great, and they would use it, but it's still something completely different to see real users using it. So therefore, we chose really to build only an MVP with the most minimum features that we could offer, the content upload, the social features, but not much more around. And this allowed us to get to the market after only a few weeks of development. And the other contributing factor to that one was that we chose to go with a rather simple tech stack. We could have invested into microservices from day one, but we wanted to get to the market as soon as possible, wanted to reduce complexities. And even today, we still have a very similar tech stack in terms of frameworks and languages, and are therefore quite happy with the choice that we made back then. So then basically it was September 14th, the day that one of the bigger federal states in Germany was going back to school, and we pressed the button to launch the app to the Play Store and the App Store, and we were waiting for the first users to join. But then on the first day, only a few hundred users had downloaded the app. We were quite desperate, and yeah, did we do something wrong? Are we really on the right track? But then on the next day, we had a small influencer campaign back then running on TikTok that we didn't have much hope actually into, but that video really went viral and brought us up to around 20,000 users in a few hours in the afternoon. So at that point, we saw that we were actually onto something and that we could potentially really build something bigger. But then with the first few users using the platform, we also run into the first few scaling limitations. So on the one hand, we iterated a lot on the product. On the other hand, we also had to really get the basics right and ensure that users can use the application without high latencies. Since at that point of time, especially during peak traffic hours, we were running on high CPU utilization on the database. So the database was the first thing that we touched back then. The main area that we had to invest into in the early days was just getting the basics really right. Optimizing queries, setting the right indices on the database, but then also pre-aggregating data. For example, for statistics or leaderboards, we don't need to have real-time data. It's completely fine to run a scheduler once per night that calculates, pre-computates the data. Then when students are actually accessing the platform, we don't have any issues with load on the database. At that point of time, we then also introduced caching, and especially for content pieces, for items that are not changing that often, this also reduced the load on the database by quite a bit. A bit later, we also then found one other bigger lever for us, which is basically a batching request. For example, if 50 students are liking a content piece in the same second, we don't need to send 50 queries to the database. But what we rather are doing is that we internally built a library, which we're also planning on open sourcing quite soon, which is a request, our so-called request app collapser. And basically, it combines 50 requests into one request if they happen in half a second. and therefore we only need to hit the database once, and therefore can also have much less load on the database, and therefore provide a better experience for students. Another area that we invested into was database replication. On day one, we were running one database instance, which was used both for write operations, but on the other hand, also for read operations. Then we decided to add read replicas to our clusters, and in our case, around 90% of the traffic is read only. So therefore, we have much more read operations compared to write operations. And basically, these read replicas are copies of the database, which are a few milliseconds behind. And therefore, on the application side, we then always need to define, do we want to now use the read replica, or do we want to use the primary instance of the database? Later on, we also added auto-scaling to the read replicas, which also allows them, again, during peak traffic hours, have high availability, but during the night, be cost efficient and resource efficient by horizontally scaling down. Two other areas that we heavily had to invest into was, on the one hand, the search. To be completely honest, with the first version that we built, the search was just one SQL query that was checking whether the keyword that the user entered was part of the title and the description of the content piece. And for sure, since users do make typos, users sometimes enter keywords that are semantically similar but still different, we had to invest a lot into the search. Therefore, decided to use Elasticsearch as our main search solution, and even still today, search is one of the areas that we're investing heavily into, since search is the way how students find the right content on the platform, and therefore it's one of our core areas of focus. Later on, in the beginning of this year, we also decided to revamp the search again a bit by switching from normal keyword search to hybrid search, meaning a mixture of keyword search and, on the other hand, a vector search, semantic search, to also capture the meaning of the search query of the user, and therefore to provide even better results, which also had a huge impact in terms of our metric of the search fill rate. Apart from that, we also had to invest into, or we saw that there were quite some issues with third-party APIs. We're sending quite a lot of push notifications for all sorts of social interactions, emails, integrating with third-party payment providers, and those were causing quite some bottlenecks on the monolith. So therefore, we decided to split those into a separate service, and those services are rather dumb service. They just receive a message from a queue and then forward them to a third-party API. And therefore, we are able to keep the latency on the main monolith low, and then only to send those requests from a third party or from an asynchronous service, which also gives us more fault tolerance in case, for example, a third-party API is unavailable for some time. It doesn't have any impact directly on the users. For sure, next to all those technical improvements, we also invest a lot into iterating on the product and trying to find a product market fit. So therefore, the main way how we are working with a product or how we are improving our product is by running A/B tests. A/B tests is a way for us to have a baseline, have the normal version of the app, and give this one to 50% of the users, and then make a change and only roll this one out to the other 50% of the users. And then by checking after a certain period of time whether the change was positive, whether the change had a positive impact on our metrics, we're able to be quite metrics driven and are quite confident in the changes that we are making, are able to generate learnings from those experiments. And by now, we really have this product principle that every single change that we are making needs to be an A/B test. Might be a small copy change that we are running, might be a bigger feature that we are hiding behind a feature flag and therefore are able to run as an A/B test, or can also be algorithm changes. For example, in case we are working on the search, to then only roll them out to a certain percentage of users and therefore see whether they have a positive impact. During during this period of time, we basically made two bigger learnings. On the one hand, we learned that we didn't build the perfect product from day one. We didn't have product market fit, so therefore it was okay that we didn't make everything perfect and optimize every single step from a tech perspective. And still today, this is one of our guiding principles to avoid premature optimizations. For sure, things evolved a bit over time now with more than 9 million users that are using Knowunity. We need to also make upfront investments into scalability and reliability, but still we always try to be reasonable with them and to avoid those premature optimizations. On the other hand, one big learning for us was to really run every single change as an experiment, as an A/B test, because this is the only way how we can really see that we are going in the right direction with our product and how we are able to make changes confidently and then generate learnings out of those changes that we are making. So at that point of time, the app was growing quite well. More and more students were joining the team. That was also the point of time when we got our first bigger funding round, our seed funding round, which was led by Project A, which then also allowed us to grow the team a bit. At that point of time, we got our first engineers on board, a data analyst on board, a product manager on board to further scale up and to further accelerate the growth that we have. So on that side, we also then had to make some thoughts around how do we even want to work together as a team. Back then, it was just us three co-founders on the technical side that were making all the changes. So we didn't need any big workflows or processes. We were just aligned and knew what we were doing. But then later on, when we had the first 3 team members, we had to invest into some workflows, some smaller processes. For example, setting up daily stand-ups and setting up things like sprints to be able to plan the work and to go in the right direction. Apart from that, we also had to make some thoughts around how do we even want to steer the company in the right direction? How do we set focus topics for the whole organization? So on that side, we decided to go with the OKR framework, which is basically a way for us to break down our long-term mission and vision of building the global platform for students, the daily learning companion for students, into our strategy for the next 3 years, and then to break those down into objectives that we have on a quarterly basis around 3 bigger focus topics that we are measuring and that allow us to see whether we're going in the right direction. Then we further break those objectives down into key results. And then in the end, every single team has their own key result. And this way we can see whether we are on track, whether we're going in the right direction, and to see whether we need to do anything or whether we need to do any changes. At that point of time, we were already running quite a few A/B tests. And we had one big issue, which was that we had a lot of different data sources, but weren't really able to combine them properly. We had, for example, our backend data. We had front-end data in Firebase, front-end data from the website on Google Analytics, but it was always quite a bit of a pain to get all of this data together and to properly work with the data. So at that point of time, we decided to build our own data warehouse. In the early days, this was a ClickHouse for us, which is an open source column-based database. Later on saw that it is a good solution, but it is just a lot of maintenance overhead for us, and therefore decided to go with a commercial solution, and decided to go with BigQuery in the end. And even today, the setup of the data warehouse is still quite similar. We have this one big events table that we use to store the majority of front-end interactions in, and therefore are able to have quite a good overview of how students are using the application in the end. Apart from that, we also invested into how we are actually able to use this data and leverage the data later on. So we set up our BI tool and allowed everyone from the company to use with the data. And one special part of, about our culture at Knowunity is actually that not the data team is only working with the data, but rather that the whole organization is working with the data. Everyone has access to the data. The majority of the team is able to write SQL queries, and therefore all different departments and product marketing are all able to work metrics driven and are able to prove their hypothesis that they are having in the end. And apart from that, we're also using the data from the data warehouse to ingest it back into our production systems. For example, for our recommendation systems, for other algorithms, we aggregate the data on a daily basis and then put them back into our production systems. The 3 big learnings during that period of time were for us that we need to avoid unnecessary processes. For sure, we needed to implement some processes to work together as a team. We needed to get a bit more mature, but still we saw that a lot of processes just create a lot of overhead, reduce flexibility a lot, and therefore we're always looking into how can we avoid unnecessary processes, make the organization more lean and be more flexible with changes. Apart from that, one big mistake that we actually made in the early days when we started to grow the team was that we built 2 separate teams. On the one hand, the engineering team, and on the other hand, the product team. And they were not really working well together. The product team was discovering new initiatives. The engineering team was then implementing them, but didn't really have any ideas around why we are even making those changes and how those A/B tests in the end turned out. So therefore, we very quickly decided to bring the two teams together and to let product managers work very closely together with engineers, to allow engineers to also have a say in how a product is evolving. Since engineers, they do work with a product all day long, they always, or they in most cases also have a very good understanding of the product. And therefore, it allows us in the end to be quite efficient and combine the skills of both product and engineering in the end. Apart from that, as I mentioned, we made sure that a large majority of the team is able to work with the data, is able to write SQL queries. And nowadays, one part of the onboarding is also that people go through a SQL course and learn how to work with the data, so that they can not just blindly make changes, but rather work with hypotheses and then validate them in the end. A bit later, we then also decided to expand with Knowunity. At that point of time, Knowunity was only available in the DACH market, but not yet outside of Germany, Switzerland, and Austria. So therefore, to further get closer to our mission of building the global platform for students, we decided to bring Knowunity at that point also to France. And that for sure also meant that we had to make quite some changes on the technical setup, had to adapt the schema of the database to be more agnostic to different countries, had to put translations into place so that students have a localized version of the app. At that point, also built a way for us to push translations over the air, meaning we don't even need to do an app update anymore in case we're just changing a copy, but we can rather control the translations from the backend side, and therefore are quite flexible when it comes to translations. At that point of time, we also had to make some thoughts around how does the product that we are building, how is it even supposed to look like outside of Germany. There were different ideas. So we want to build the same product, or we want to make adjustments, since for sure the education system also works a bit differently in France. And at that point, we decided that we want to actually keep the product as similar as possible, since still education, there are some differences, yes, for sure. But education does still in the end work quite similar in most countries. And for us to be able to scale, to bring Knowunity to as many markets as possible in the future, we needed to keep the complexity down and therefore build one product for all markets instead of building different products for different markets. At that point of time, we also decided to one bigger engineering principle, that we would never ever hard code any country information, for example, in the app, but we'd rather build a system around config flags and feature flags that allow us, if there are still some small changes which are necessary between different countries, that we would be able to change them from the backend side and not keep any of this logic around how countries are supposed to work in the app, but rather keep everything agnostic and use feature flags for this. Later on, the team then also started to grow. We back then had one product engineering team that was getting quite big. Daily stand-ups were getting quite long. There was not enough focus on one clear metric. So therefore, as the team was scaling, we decided to split the team into smaller squads. And the way that we split squads was basically around our product metrics, our main MP results that we set per quarter. And those product teams, those product squads are able to influence their product metric using A/B tests. On average, nowadays, every single product squad runs around 5 A/B tests per week, and this way we are able to impact our metric quite well, and are able to see whether we're going in the right direction. Apart from that, we also saw that we needed to invest a bit into sort of the foundations, and therefore build a platform team. The platform team has the main task of enabling the product team and making sure that the product team can work as efficiently as possible. So therefore, the platform team is working on a lot of foundations, services that they offer to the product team for them to move as fast as possible. And it's also taking care of things like the underlying infrastructure and security, so that the actual product squads don't need to worry too much about those tasks. As we were running around 5 A/B tests per week per squad at that point, we also saw that our current approach to A/B testing was not really scalable anymore. At that point of time, it was just one large file in the backend that contained all of the A/B tests, which did work, yes,
But on the other hand, it only allowed engineers to start new A/B tests. Product teams didn't really have a good overview of what different A/B tests are currently running. So therefore, on the one hand, we decided to invest into building a front end around our experimentation platform. And nowadays, every single person from the product and engineering team can just start their own A/B test by specifying the date duration, by specifying the cohort in which they want to run the A/B test and the different variants, including their respective feature flags, and is then able to start a new A/B test. We also invested a bit into the actual evaluation of the A/B test by building our own tool that allows us to just enter an A/B test, allows us to enter the metric that we are optimizing for, and then shows us whether the A/B test is statistically significant or whether it is not. And this way allows us to make decisions on whether we want to roll out those A/B tests or whether we still need to iterate on them. With more and more users joining Knowunity, we also saw our first few growing pains with our infrastructure. From day one, we basically were using Elastic Beanstalk as our main hosting or main deployment platform on AWS. And it was definitely working quite well in the majority of cases, but it was just quite hard for us to operate it properly at scale. Therefore, we then decided to migrate to Kubernetes, running on EKS, provisioned using GitOps. And for sure, on the one hand, it was quite a steep learning curve, but on the other hand, it nowadays allows us to run our backend applications in quite a reliable way, allows us or brings us quite a lot of flexibility in terms of setting scaling triggers based on queue sizes or other external metrics, allows us to plug in logging, and also allows us to make use of pre-made Helm charts to save quite some time when it comes to hosting open source solutions. The main two learnings from this period of time was, on the one hand, that we need to build one product for all markets, that we need to keep the difference between markets as small as possible, and only this way we would be able to actually build a scalable product on the long term. Apart from that, we also saw very well that smaller teams are actually working much better compared to larger teams, since they can avoid a lot of alignment meetings, can really clearly focus on their one key metric, and therefore we were able to reduce quite a bit of overhead by having those smaller product squads which are focusing on one metric in the end. And that also already brings us to the beginning of this year. One of our biggest milestones so far, bringing Knowunity to the US, which for sure also from a technical setup, or from a technical point of view, brought quite some challenges for us. So until that point of time, we were mainly running Knowunity in one data center in one region of AWS in Frankfurt. And this was also working quite well, since all of our markets were situated around Germany. And therefore, also users, for example, in the UK or in Italy had quite low latencies. But then when it comes to the US, there's always the ocean for sure in between. And for every request, this means that it adds around 90 to 100 milliseconds of latency on top of the actual request. So therefore, we made quite some thoughts around how do we want to, or do we need to build a multi-region setup? In the end, we iterated quite a bit around this multi-region setup, and decided to go with the following structure. One of the main requirements for us was that we wanted to be able to also share data between different markets. For example, content that is created by a UK student is also super relevant for students in the US. And therefore, there was a need for a certain syncing between the two regions. So what we did was that we basically kept the European setup as it was, with the backend application being hosted there, the primary instance of the database being hosted there, and the read replicas being hosted there of the database. But we added an additional backend application in the US region on AWS, also added read replicas to this region. And this way, for all read operations, we're able to have low latencies both in Europe and in the US, since European students, they always go to the primary region, and US students, they always go to the edge region. But then when it comes to write operations, we saw different possibilities. The most obvious possibility would have been that for write operations, we also go from the backend application in US to the primary instance in Europe, which also worked in our proof of concept. But we then later saw that this is not really scalable for us. Since, for example, in case you're working with a database of transactions, every single query inside the transaction needs to travel from the US to Europe, which adds several seconds of latency in the end, and therefore gives the users a bad experience on the one hand, and on the other hand, also causes more load on the database, since the database needs to handle more concurrent long-living transactions and also more concurrent connections. Therefore, what we did instead is that we differentiated between high-priority write requests and, on the other hand, low-priority write requests. For high-priority requests, for example, if the user creates a content piece, if the user signs up, we need to acknowledge that the change that the write operation was successful. Therefore, for those operations, we just directly proxy them from the American region to the European region, and just then adds around 90 to 100 milliseconds in terms of latency on top of that. But then for low priority write operations, for example, in case the user likes the content piece, in case the user starts following another user, we don't need to directly acknowledge that the change was successful. We just write those changes to a queue, and then the queue messages are being forwarded to the primary region and are then being executed a few milliseconds to seconds later. And therefore, also for those types of operations, we're able to keep the latency low. And this setup only worked for us because around 90% of our operations, 90% of our requests are read-only. So therefore, since in case of read operations, you go directly to the read replica in the local data center, latencies are low both for American and for European students. In case of low priority write requests, which are around 8% of requests, there's also no additional latency, since we're just writing the message to a local queue and are then forwarding them. And only in terms of high priority write requests, which are around 2% of our traffic, we need to add those 90 to 100 milliseconds of additional latency. And this is definitely feasible since they are only a small part of our traffic in the end. In case of our search setup, we also went with a quite similar setup, had a primary, or still have a primary cluster in Europe, and then read replicas in our edge region. Only for the caching on Redis, we decided to go with a bit of a different setup, since there's no need to actually keep the cache of both regions in sync. We only need to worry about invalidating the cache and change in case, for example, the content piece changes, and therefore could keep also the complexity quite low on that side. And in the end, the main advantage of this setup is that we have one primary region and can also add additional edge regions in the future. For example, if we are deciding that we want to now also expand to Asia, to Africa, and we can just add an additional region over there, and therefore also ensure low latencies for users on other continents in the future. And at that point of time, we were then also starting to organize our first MQ hackathons at Knowunity, which is nowadays a big part of our culture. We're organizing around 3 hackathons per year. And the big and positive thing about those hackathons is that actually 80% of the initiatives that we build during the hackathons, they end up in the app in the end. So therefore, this also shows us that engineers have quite a good sense of product, what then does actually work in the end. And therefore, those hackathons are a very crucial part of our culture, and also a crucial part for us to come up with more ideas which are a bit out of the box and a bit out of the ordinary. And then it comes to another big topic, which is generative AI, which is disrupting many different industries, one of them being education. And on that side, we decided to build a few different functionalities around generative AI. One of the main ones for us is this AI buddy, how we're calling it, because we basically see that only very few students are able to afford their own tutor with whom they can study, with whom they can do homework together. But most students actually have the need for being able to study together with someone. So therefore, what we did is build this AI buddy, which is able to replicate parts of this tutoring experience, have integrated it quite deeply into the platform. It knows a lot about the student, about the weaknesses, in which topics is the student strong, and which topics does the student still need to improve. And we are quite uniquely positioned at that point, because on the one hand, we're able to leverage the data about the individual students and are therefore able to give the student quite a unique experience. And on the other hand, since we have 9 million students on the platform, we are also able to combine different data points of different users, for example, are able to find out dependencies, relationships between students, and therefore can, for example, come up with suggestions based on if a student if a lot of students first study topic A and then topic B, it's most likely that there's a certain dependency between those topics, and are therefore currently building a knowledge graph that even further allows us to uniquely leverage the data that we have. Apart from that, generative AI was also a big lever for us internally, since it allowed us to optimize quite a few processes that we have internally. For example, one of the things that we need to do with every single app update is to actually translate the copies into the respective languages. And therefore, we are also nowadays leveraging generative AI, are leveraging large language models, are able to pass a lot of context about how our app is working in the end, are able to pass a lot of context around the newly developed features and the original query, the original copy that we have in English. And therefore, we're able to highly improve the quality of copies that we have, and also reduce operational efforts that we had around translating copies into the respective locals. And that already brings us sort of to our final learnings. On the one hand, during this period of time, we really learned how important it is to focus on the most important topics. There was a period of time where we were doing tons of different things and didn't really focus enough on the most important topics. For example, one of them being our US expansion. And therefore, especially this year showed us again how important it is to really focus on the 3 bigger topics, and then to take them forward instead of working on hundreds of different smaller topics that in the end don't have really a big impact. Apart from that, we also learned how important it is to really optimize every single process that we have, every single technical setup that we have for speed, since especially with this rapid A/B testing approach that we have, in the end, what counts is that we're iterating as quickly as possible, and we're generating a lot of learnings out of the A/B tests that we are running. And therefore, the iteration speed that we have with those A/B tests, around 5 per week nowadays per squad, is super relevant for us. And we're still optimizing processes a lot internally, or workflows internally, since we like to avoid processes. And on the other hand, also to improve the technical setup, to not have a too much complicated technical setup, and rather to build the right abstractions so that the engineering team can move as fast as possible. And then on the other hand, one big learning for us was that generative AI is really a huge opportunity for us. It didn't change much about the vision of our mission that we have with Knowunity, which is building the daily learning companion for students. But we're just able to get there much quicker than we initially expected now with generative AI and large language models, and therefore are able also to make use of those new evolutions of technology. And that already brings me to the end, to the typical slide. We're always also looking for new team members who are keen on joining a fast and growing startup. In case you're interested, feel free to check out the website, also to reach out to me later, and I'm happy to answer all of your questions.
So how's your quality assurance been decided on? I think so. If you education pretty sensitive to a quality of content, if it's mass created content, quality is mostly the problem. So you go in the mass. That was probably the Yahoo mistake, to go in the peak of quality, and then they couldn't scale the content. But if you want to scale the content, you have to take the shitty one too, and the education system is quite sensitive to that. So how did you at the end find your mechanics for this curation of quality?
Yeah, very good question. Basically, when it comes to the quality of the content, in the very early days, we were manually reviewing every single piece of content that was uploaded to the platform, which allowed us to acquire quite a lot of high qualitative content. Over the course of time, we saw that for sure that this is not really a scalable process for us. So therefore, nowadays we have 3 main levels. On the one hand, we do have some machine learning models in place that are able to detect certain parts of the quality of the content piece. For example, things like, is the photo that's being uploaded by the student of high quality? Is it does it contain any plagiarism from the internet? These kind of things. On top of that, a certain piece of content where we are not able to say with high confidence that it is of high quality, we still review those manually. And then the third and biggest lever for us is actually the community, because the community works with those content pieces. And if they get more interaction with the content pieces, if they like them, on the other hand, also if they report them, we're this way able to gain quite some unique metrics around how good the content piece is in the end. Yeah.
What are the main squad metrics and how did you choose?
The main squad metrics for us are around the key results that we're focusing on. So, for example, one of the squads is focusing on retention. One of the squads is focusing on the search, and at the moment the other squad is focusing on monetization, and the latest squad that we added is focusing around the AI topics. And we're always trying to find metrics that go in line with our long-term vision. And therefore, the metrics are being decided on the one hand by us founders, and then together with the product managers, to see that on the one hand they are feasible to reach, but on the other hand that they are also quite ambitious, so that there needs to be some work to actually get to the metric in the end.
Now, so the question about the experimentation around special content of divided the teams, having them focus on metrics, that I assume that might be the case that still different teams are working on similar parts of the platform. So with the amount of experiments you're running per week, how do you manage to not cross-pollinate? How do you know that, how do you manage this whole process and actually getting the real results?
Yeah, good question. Basically, in the early days, this was a big problem for us. But nowadays, the squads, yes, they have a core metric that they're working on, but they also have a certain area of ownership of the product. And therefore, it only happens very rarely that two teams are working on exactly the same feature. And on top of that, what we built recently, which is sort of an addition to our evaluation platform, was that we're also having a lot of metrics around whether there's any cross-contamination of A/B tests, whether the cohort sizes are big enough, that there are no overlaps between cohorts. At some point, we decided to not only run the A/B tests, or like run those 15 A/B tests that we're running per week as individual A/B tests, but rather to merge them into one larger A/B test as a multi-variant A/B test. Then all of the 5 experiments that the squad developed in 1 week, then they're running as one bigger A/B test. That there's no overlap between the different A/B tests. But for sure, this is only possible nowadays since we have quite a big amount of users that are using Knowunity. And in the past, this was not really possible, since if you make the cohort sizes too small, it is quite hard in the end to reach statistical significance, and therefore to have a result that we are confident in.
So just to clarify, if I understood correctly, so now with terms of batching of those experiments, you just kind of push, let's say those weekly 5, and then just go or not go.
Not go on go, but rather we evaluate those individual cohorts individually.
Yeah.
So if one squad is working on 5 different experiments, we have 6 different cohorts in the end, the baseline plus the 5 different new experiments or new initiatives that we're running, and we're checking for every single cohort individually whether they had a positive impact, a statistically significant impact on the metric in the end, and only then roll out those experiments, those variants that were positive in the end.
Regarding the hackathons, what kind of tasks do you give teams, and are these mixed teams or internal colleagues, only external? How do you organize them?
Those hackathons, they are actually internally, and in the beginning, for the main the hackathons were rather generic. Engineers could work on whatever topic they were interested in. But for example, for our last hackathon, we decided to focus them on one big topic, which in case of the last hackathon was around AI, and therefore set a bit of guidance for the teams. But in general, we see that both types of hackathons, guided hackathons and also non-guided hackathons, work quite well and had positive results for us. And in terms of the teams, it's mainly the engineering and data team for us, which is joining the hackathon, and they are forming completely new teams. For sure, it's mostly teams consisting of one backend engineer, one data analyst, and one mobile engineer. So all different areas of expertise are represented in the individual groups. But apart from that, the teams are free to choose what they are working on and are then in the end presenting their results to the whole organization.
I hate to interrupt, but I'm afraid we have run out of time. Thanks a lot, Lucas. Super interesting.